Okay, good afternoon, guys. So today we'll be focusing on analytical geometry. We are continuing. This is lesson 2 on analytical geometry. So I said in this lesson I will be speaking about quads, right? So uh, for us not to waste time, I will just tell you guys the properties of the quads, right? Specifically, let me just focus on the important ones, right? So let's say, for example, let's focus on a square, a rectangle, a rhombus, and a parallelogram, right? So a parallelogram is something like this, something like this. So this is a palm. You can just open your textbook and read the properties. So a parallel, you will see a parallelogram by opposite sides being equal, right? And opposite angles being equal, those things, right? And parallel, you understand? So that is how you see your parallelogram. Even your rectangle, for example, but then in a rectangle, you have your angles being right angles. So you have right angled angles like in your rectangle, right? Okay, then even in your square you have right angles, right? But then remember, so we are in analytical geometry. These things, they are important, they are very important. That is why you must do analytical geometry after you have done Euclidean geometry, because you'll be having a background information about your quads, right? So this is a lesson of analytical geometry. I can't be focusing on quadrilaterals, right? So please go and read properties of quadrilaterals. So, but then what I want to emphasize is that the gradient, we spoke about the gradient being y2 minus y1 over x2 minus x1. This was what? Our gradient, right? So we are just doing a recap on the previous lesson. We spoke about the gradient, and we spoke about that the gradient of parallel lines is equal, but the product of the gradients of perpendicular lines is equal to -1. That means that if you want to prove that lines are perpendicular, you are going to take the product of both lines gradients. If that product gives you -1, that means those lines are what? Are perpendicular, right? And if they say prove that lines are parallel, you are going to calculate the gradient of both lines. If the gradient of both lines gives you the same answer, that means that those lines are what? Are parallel, right? Now let's go inside. You know the area of your triangle is what? Is half base perpendicular height, right? This is the area of your triangle. For example, so this area was taken from a right angled triangle, right? So if we have something like this, we have 90 degrees, meaning that we have perpendicular lines, right? So this means that this area, you can only use it if you have perpendicular lines, right? So we can see this is our height, perpendicular height, this is our base, right? So this will be half our base, which is BC, perpendicular height, which is what? Which is AB. So this is the formula of the area of a right angle triangle, right? So for us in analytical to be able to calculate the area of our triangle, what are we going to do? If we have 90 degrees, it's going to be easy for us to calculate, right? Then we have another type of triangles. Maybe you have a triangle like this, but they gave you the height here. They give you the height here, right? And they told you that it's perpendicular. So you can calculate the area of this triangle using two methods. You can just use your base. You can just take your base as BC. Then your H is your H, right? Or you can calculate the area of what? ABD and ACD. So of ABD will be half H multiplied by what? By BD. Base is BD, perpendicular height is H, which is AD, right? And calculate the area of the other triangle, which is ACD. Then add those two areas, you're going to find what? Your area of your ABC, right? Okay. Now let's continue. Then we have types of triangles, right? You must know your types of triangles. So let's say you are supposed to prove that a triangle is an isosceles triangle. You know that an isosceles triangle is ABC. We have two sides that are equal and two angles that are equal, right? So when proving that your triangle is an isosceles, you can just check if there are two sides that are equal. If you have two sides that are equal, then that means that triangle is an isosceles. But remember, you must calculate all sides. You must calculate AB, AC, and BC, because you can calculate AB and find 5, AC and find 5, and then you conclude that it's an isosceles, whereas even your BC it's 5, finding that this is an equilateral triangle. So be careful. For you to conclude that this is an isosceles, you must calculate all the sides. Then if only two sides are equal, then it's an isosceles triangle. But if all sides are equal, it's an equilateral triangle. In an equilateral triangle, all sides are equal, even all angles are equal. Then we have a scalene. Scalene, there are no sides that are equal, there are no angles that are equal. Right? So those are the most important things that you must take into consideration when going to analytical geometry. Now, let's get straight into analytical geometry. So we are going to use a Cartesian plane. So we have what we call a Cartesian plane. In analytical geometry, we will be focusing on this thing in most cases. So a Cartesian plane is something like this. You have seen it before. So you have an x and the y axis. So this is your y axis, this is your x axis. So this is what we call a Cartesian plane. So you have 1, 1, 2, you have your values, right? -1, you know this side is negative x's, this is negative y's, this is positive y's. So this is what we are going to use in analytical geometry, right? So let's go inside analytical geometry. So now, for example, let's say they are saying calculate the distance. We have the distance formula. Remember, the gradient formula was y2 minus y1 over x2 minus x1, right? Now we have, this is the gradient formula. Now we have again the distance formula. So the distance formula, what does this mean? You're asking yourself, what does this concept distance formula mean? So distance formula simply means that, for example, let's say we are calculating the distance of AB. We are going to say AB is equal to square root of what? X2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula, right? So you must just know it by heart. This is the distance formula. I will show you how you see your x1, x2, and y1, y2 when we have coordinates, right? Then we have what we call the midpoint formula. So what is a midpoint? A midpoint is where two lines meet. For example, if we have a single line that is bisected by this line, we have A, B, C. You are given that AB is equal to BC. So the midpoint of AC is what? Is B. This is what is the midpoint. So the midpoint formula is like this. So I want to put it in a way that, in such a way that you understand what does this mean. So because, okay, I will come there. So the midpoint formula, it says x value of midpoint is equal to x1 plus x2 over 2, right? And the y value of midpoint is equal to y1 plus y2 over 2. Reason we are calculating the x value and the y value is because of, remember, a coordinate consists of an x and a y, right? So in this case, we are going to calculate our x using the x value of midpoint, then our y using the y value of midpoint, right? So you must be careful, but then when calculating this thing, at some point they can give you a point and the midpoint and say calculate the other point. For example, Let's say they can give you a line, right? They say A, you have 2 and 5, and they say B, you have 3 and 7. And then C, they say calculate the coordinates of C, and they tell you that B is the midpoint of line AC. So what are you going to do here? That's why I break this formula into this. In this way, you are able to understand it. So in this way, you are going to say x value of midpoint, you have it, right? This is your x value of midpoint. This is your y value of midpoint. Then you can just say this is your x1, this is your y1. Then here you are calculating your x2 and y2. That's what you can do. And substitute into your formula. So you're going to find your x2 and the y2. Your x2 using the x value of midpoint formula, and your y2 using the y value of midpoint formula. So I will explain those concepts while we are doing questions, right? And I would like to explain further about finding the equation of a straight line. So remember, we can just use y is equal to mx plus c, where you'll see it's your y-intercept, right, from the linear graph. And your m is what? Is your gradient. So you start by calculating your gradient. After calculating your gradient, you can use any other point that is on your straight line to find the value of c. Right? Okay. But then I will show you guys what I mean about that thing. So this is the end of this lesson. Thank you.